For the CircuitPython Parsec today, I wanted to talk about overclocking the CPU frequency of the RP2040 and RP2350 chips. What I have set up here, this is a Feather RP2350, which now has official support from Raspberry Pi for 200 megahertz overclocking. You can, of course, go wild, go slow to conserve power, go super fast, but you risk overheating and melting things. But this is definitely a safe one. It's officially been sanctioned. And so what I'd like to do is show you how you go and check the current frequency, how you can set a new frequency, and also have a little bit of a demo on some different benchmarks for different CPU speeds. So if you look at both the screen here and my REPL, either one, they're going to show the same thing. So what I can do is, first of all, import microcontroller. You can do that right here in the REPL. You can also do that in your code, which we will in a second. Once you have microcontroller imported, you can ask for the microcontroller CPU frequency. So I've done that before. I'll just hit up arrow a couple times. Microcontroller.cpu.frequency. And it will check the current frequency of the microcontroller, of the CPU, and tell me, okay, this is actually set to overclocked to 200 megahertz. If I want to set that to something else, I can say microcontroller.cpu frequency equals, and let's set it back to the default, which is 150,000, I believe, on this chip, and I think it's 133 on the RP2040. So now, again, if we go and ask, hey, what's your frequency? It'll tell me we're at 150,000, or rather 150 megahertz. So what we can do inside of code is the same sort of thing. You look right here in my code. I'm importing microcontroller. I'm doing some screen setup stuff just so we can see the REPL on there. I have some different speeds I want to check in this benchmark. So that's my little dictionary here of speeds, or little list. And then I have an intensive calculation. So it's going to go through a whole bunch of slow math so that we can check the speed on different frequencies as we overclock and underclock this. So it'll time that, how long it takes to run through those intense calculations, and then report that at the end. And then in our main loop, what I'm going to do is for each of those speeds, I'm going to set the microcontroller CPU frequency to one of those 4 speeds, run the calculations, and do some printouts as we go. So here's what it looks like if I run that. So CPU benchmark, setting the CPU to 100 megahertz, and then I'm actually asking it, did you do that? If you don't take a little bit of a pause, sometimes it won't catch that before it starts moving on with the rest of the code. So I have it pausing, reporting the frequency, and then telling me how long it took to run that big intense calculation. So at the end, we'll get this summarized since it's scrolling by, and I can't remember which they were. And here I see, okay, there's a frequency at 100, 133, 150, and 200 megahertz. How long it took to run the intense calculation. Initially it was 5.34 seconds, underclocked quite a bit. 4 seconds, underclocked just a little, 3.55 at its native 150, and all the way down to 2.65. So we got a nice speed up there by overclocking it, a nice safe amount. And then you can push this much further. You'll want to do a little additional reading to make sure that the voltages you're working with will support it, and again, have adequate cooling going on. And so that is how you can use microcontroller.cpu.frequency to under and overclock and just clock your CPU on an RP2040 and RP2350 inside of CircuitPython. And that is your CircuitPython Parsec.